Hello all. Today we will be dealing with the topic called extrusion, which is the topic in module 3 of the subject manufacturing technology. So we have already discussed in our earlier lectures that if we classify manufacturing operations, there can be primary manufacturing processes as well as secondary manufacturing process. Primary manufacturing process was casting, and under secondary manufacturing processes there comes the metal forming based operations, joining based operations, and etc. So, extrusion is basically a metal forming operation. In metal forming operation, what does that mean? It's where we actually impart plastic deformation to the material. So we deform the material by applying strain and inducing stresses beyond the uh, elastic range of the material, beyond the elastic limit of the material, and we impart a permanent deformation to that particular object. So extrusion is basically a process where we convert a block of material into some other product which have a reduced cross section. And how we do that, we make the metal flow through a small opening, a small die orifice. And to to make this happen, we need to apply extreme high pressure. So extrusion is a process by which a block of metal is reduced in cross section by forcing it to flow through a die orifice and a high pressure. So commonly this process is employed for fabrication of cylindrical bars. We can't confine that to just cylindrical objects. What is the cross-sectional shape of, or what's the shape of the die opening? Depending on that, we can define the shape of the rod that we can obtain. So, and this is just not just for bars, this can be used for hollow tubes. And at times we can use the products that we obtain from extrusion as input material for other products. Say for example, if you remember in rolling, to carry out rolling operation we required slabs or billets or blooms, and to create slab, billet or bloom we employed the operation called casting. All right. So in case if you want to fabricate or manufacture wires or very small rods, so in that case, what we do is we generate rods, we manufacture rods using the process called extrusion. And using these extruded products, we give these materials as input to another process from which we could obtain furthermore complex or fine features, which we cannot obtain using extrusion. So both the process and the component, both we can name it at extrusion. The process is also called extrusion, and component that we're getting through extrusion can be also called as extrusion. Right? So compared to other processes, metal forming processes, the forces that we require, the stresses that we require in extrusion is extremely high. So in the case of extrusion, we apply stress from all directions. In the case of rolling, we were applying the load in a specific direction perpendicular to um, the rolling direction. However, in the case of extrusion, what we do is when we apply force onto this billet using that specific construction, the confined space will equally impart a reaction force onto this material. Say, for example, here this is what we call as a billet, which is a block of metal, and we are applying a force using a ram. We will get a more idea about this once we go to subsequent to the next slides. So when we apply a load onto this, so the metal will flow through this die opening, which we call as die orifice. And due to this, when we apply this force, the metal will deform, made to flow through this. At the same time, this container walls will apply a reaction force onto this material from all the directions. So it's not just a force by the ram from one direction, it's also the reaction forces by the container walls onto the material in all directions. So the compressive stresses that this billet will undergo will be extremely on the higher side. Plus, due to the application of this high compressive forces, at times extrusion process has also been used to break down the grain structure, to change or modify the grain structure. At times we go for extrusion processes, right? Now, how this process can be classified, extrusion process, depending on the operation conditions, depending on the direction of the flow of the material or the type of the equipment we use. So extrusion processes can be classified based on its direction of the flow of the workpiece material, based on the operating temperature, the temperature at which the billet is placed, and based on the type of equipment that we are using, whether we are extruding it in the horizontal direction or in the vertical direction. So let's go by the classification based on direction. So under the classification based on direction, the first type is direct extrusion. So let me once again define the process to you clearly. So in the case of extrusion, the setup basically consists of first the raw material called billet. Fine. We make this material to flow out through a small opening, and the cross sectional shape of the product that we're getting depend on the shape of the opening that we are providing. Now we place this billet inside a container, a rigid container. Fine. Into this we are placing the billet, and we are using a ram to apply a force onto this billet, a compressive force onto this billet. And in between this billet and the ram, we place a dummy block. So through this dummy block, we are imparting a compressive force using a ram onto this billet. And due to the application of this billet, right now the only portion through which the material can flow is this opening. Now this is what we call as die, and this is the die opening or the die orifice. So when we apply the compressive force onto this billet, through this only vacant space the material will come out. So this is nothing but our extruded component or the extruded product or extrusion. Right? So in direct extrusion, what happens is that if you're getting the material in the same direction as of the direction of application of force, we call it as direct extrusion. Here, if you look, we are applying the compressive force from right to left, and the material is getting extruded towards the left side, towards this side. So the direction of application of force and the direction of the flow of the material both are in similar direction. So this is what we call as direct extrusion. Now in the case of indirect extrusion, now let's just modify the system that we discussed just before slightly. Now here what we do is we are not providing the die opening at the end of the container. However, what we will do is that we will use a hollow ram to carry out indirect extrusion. Now imagine when we apply a force onto this billet. Now this is the billet, this is the ram, this is the hollow ram. Now when we apply a force onto this billet, what happens is that there is no opening at this end. So when we induce the stress onto this billet or compressive force onto this billet, the material should escape through some way out, right? So the only opening that it got is this opening on the ram. So what happens is that you apply a compressive force onto this material, and the material will flow in the direction opposite to the direction of application of force. If you look here, we are applying the force from left to right. We are applying the force in this direction, and the material is getting extruded in the opposite direction. Getting my point? So here the direction of application of compressive force and direction of flow of the extruded part are in opposite direction. So this is what we call as indirect extrusion. Fine. Now if you compare direct extrusion and indirect extrusion, what we could say is, first of all, in earlier case, what we used is in direct extrusion, what we used is a solid ram. In the case of indirect extrusion, we are using a hollow ram. Right? So how much force that you can impart using this ram? So since the ram is hollow in the case of indirect extrusion, the application of force is bit limited in the case of indirect extrusion. Now the second thing, in the case of direct extrusion, if you remember, we want to make the whole material flow through this small opening. So we need to displace the material surpassing the friction at these container walls also. However, in the case of indirect extrusion, we are keeping we are making this ram move relative to the container. Otherwise, at times the ram can be stationary and the container will be moving, or the container will be stationary and the ram will be moving. Usually, we prefer the first condition. We keep the ram stationary and we make the container move. Right? So, in the first case, the material needs to overcome all the frictional effects on the container walls, and finally it flows through the die opening. However, in the case of indirect extrusion, what happens is that there is no relative flow between these container walls. So the only portion where the friction is critical is only at the opening in the ram. So the force requirement in the case of indirect extrusion is relatively on the lower side. The power requirement will be in the lower side, and the frictional effects will be on the lower side in the case of indirect extrusion. Now, in a similar aspect, what we can compare in the previous case in direct and indirect extrusion, from the figures we can infer that we get solid objects, right? What if we require hollow parts? We need to fabricate hollow parts. In that aspect, we slightly modify the configuration of the system that we are using, right? Now here, in the case of forward extrusion, now this is nothing but the die, and this is the punch. Here we place a small part which is known as the mandrel. Fine. So what we do is we place the raw material above this mandrel inside the die, and we make the punch to move from up to down. So the size of the punch will be as close as the size of the opening that we have on the die. So when the sponge hit the raw material, the billet, what happens is that the material needs to flow through some opening space. So in this case, the opening space is it can flow downside. However, there is a mandrel placed here. Mandrel is nothing but a solid object. Consider it as a solid bar. Fine. So when we apply the compressive force onto the billet, what happens is the mandrel being have a small size than this die opening, the material once get compressed will flow all around this mandrel. And once the process is done, you lift the ram, you remove the mandrel, and you will get a hollow component. Now just try to understand whether this is a direct extrusion process or indirect extrusion process. You remember in direct extrusion the material flows in the same direction as of the direction of application of force. So in the case of forward extrusion, you are applying the force from top towards the bottom side, and the material is also flowing from top side towards the bottom side. So forward extrusion is similar to direct extrusion concept. In the case of backward extrusion technique, what happens is you have a die, and see, the ram that we are using is of a smaller size compared to the die opening, and we are closing the bottom side. So what happens is once the material comes into contact with the billet, the only vacant space that the material go to flow out is around this ram. So it will flow all over the ram. So in backward extrusion, we apply a load in the vertical direction from top to bottom, and the material is flowing around the ram in the opposite direction. So backward extrusion is similar to indirect extrusion.